All right, guys, so properties of logarithms. So what I want to do, kind of refresher here is that let's go over some of these old rules of exponents that should have come up in your algebra days here. So for example, part A, if you had x squared times x to the third, if you remember on those are the cases where you can add exponents, x to the fifth. And the reason that works is, as a real quick refresher, x squared, of course, is just x times x. And x to the third is x times x times x. So if you look at those and kind of count those up, you have 2 of them and 3 of them, so that's why you can add the exponents and end up with an x to the fifth for that one. Similarly, part B, if it's a division problem and the bases are equal, you can go ahead and then subtract exponents. This would be x to the negative first, okay, 2 minus 3, which should probably be written as a 1 over x to the first, and avoid having a negative exponent. We can always think reciprocal. And in the third case, another basic property of exponents, if you have x squared to a power, this one's known as like power to a power, and you actually multiply in this case. So x to the 2 times 3 is x to the sixth. And again, the reason on that, if you think about what's going on here, x squared, of course, is x times x. And you have that to the third power, so there's 3 of them. And that's how you end up with basically 6 factors of x. Okay, so those are some basics. They're going to kind of definitely tie into play here because logarithms and exponents are very closely related. If we recall also, when you evaluate a logarithm, you're finding what exponent you raise the base to. Okay, so for example, log base 2 of 32, if we say that equals x or something, we don't know what it is, let's try and solve it. It's basically saying, what power, okay, because if we rewrite it, the base was 2 to the x power, right, equals 32. A logarithm is saying, what power do you raise something to? And in this case, 2 to the fifth power equals 32. So we would know that in this case, x would have to equal 5, and that means the log base 2 of 32 is 5. Because again, 2 to the fifth power equals 32. So logarithms are really exponents, right? A logarithm is just an exponent. It's saying what power do you raise the base to get to become the number here. Okay, so let's keep those in mind. Let's take a look at a couple other properties here. Okay, so if we recall one from the previous slide, if we have a base to a power to another power, we can multiply exponents together. So with logarithms, if you think of it in a certain way, think of log base b of x. Okay, remember a logarithm is an exponent, so that's really like a power, the part I highlighted, and it's raised to another power. Okay, so it's really like a power to a power. So what you can do on those is you can multiply together. Okay. So we see it ends up being m times log base b of x. So what really, kind of visually, you can just think of bringing that m out as a multiplier, and it ends up being m times whatever that log is. So let's look at a numerical example. If we have log of any base b of 3 to the second power, what I can do is take this power and bring it out front and multiply it by the log base b of 3. Okay, because again, the log itself is an exponent being raised to another power, so that implies multiplication. Okay, if you recall, okay, the previous slides, right, we have same base being raised to a power. We are able to add exponents. Okay, so if you think of, or if you look at this side of the equation here, we have an exponent and we're multiplying, right? It's the argument there is m times n. What the rule is that we can add exponents. Okay, so let's take a look at this with a specific example as well. Okay, if you have the log base b of some product, right? 5x is 5 times x. We could split that up into log base b of 5 plus, right, because this is multiplication, so it relates to addition with exponents, log base b of x. Okay, and what might be more useful, okay, is actually going to be taking something like this, and instead of expanding it, we can condense it into a single logarithm this way. Okay, so we'll be doing both. Okay, one more example, one more property that we saw. Remember the quotient property. If you have a division problem, you subtract exponents. So if you have the log of a division problem, okay, or the log of like a fraction, you will subtract logs. Okay, so for example, the log of any base b of 3/5 could be written as log base b of the numerator minus log times whatever the base, or not times, but log base b of the denominator. Okay, and similarly again, we're going to probably be doing more often where I will give you something like that, or you'll see something like that in an equation, and you'll need to, it's called condense it into a single log instead of expanding it. But if you just remember again, division, okay, division definitely relates to subtraction of exponents. All this stuff's not totally brand new. Just remember your rules of exponents, and they definitely apply here. All right, so let's just take a look at a couple other examples here where we actually want to condense. So these are just your exponent rules over here. Let's take a look at this example here, though. If we had the log of any base, we'll talk more about log base coming up, but if there's no base written, it's assumed to be 10. So let's say we have log base 10 of 5 plus log base 10 of 10. So since both bases are the same, I can write this as log base 10 of, since it's addition, we're going to do a multiplication. Okay, 5 times 10 is 50. This one is subtracting two logs of the same base, so we are able to divide their arguments. 10 divided by 5 is 2. And then here's the case where we have a log being raised to a power, so that power, that exponent can be brought out front. This would be 2 times log base 3. Or not, I'm sorry, not base 3, log of 3. All right, so let's expand a little complicated examples here. Let's see what we got going on. Can we take an expression like log base 5 of 2x over y squared, and we want to expand it? We want to use our properties and expand this thing out. So what I'm noticing, and what hopefully you guys are noticing, there is a division, okay? So when you see division with exponents or logs, automatically think subtraction. So what I'm going to have is log of the numerator, 2x. Actually, we did have a base given, log base 5 of 2x, minus, since it's division, log base 5 of y squared. Okay, now there is one more thing we can do. Okay, since we have an exponent there, okay, we can bring that out front. Okay, and I'm seeing one more thing we can do on the first term as well. But let's finish this one out. I'll bring the 2 out front. Okay, so we can do that. Okay, that's that property power rule. Now there is one more thing we could have done. Again, we have the log of a product, right? 2x is 2 times x. So we could, and we should, expand this out into, since it's multiplication, right? 2 times x, we're going to do it as addition. Log base 5 of 2 plus log base 5 of x minus 2 times log base 5 of y. Okay, so that is expanding. We took a single expression, right? We took like a simpler expression and we kind of expanded it out. All right, now how about this? Can we rewrite, okay, into a single logarithm, or condense is kind of a word that you'll see used in these problems. And this is the more common one because, again, it's going to help us solve equations. But let's take a look. So we have an addition problem, right? So I'm automatically thinking multiplication, okay? We also have in this problem multiples out front, coefficients out front, okay? Those coefficients are going to become exponents, okay? So what we have, if we just do one step at a time, that 2 is going to become an exponent. We have log base 3 of a squared. I'm not doing anything with the addition yet. I'm just doing the exponent. Log base 3 of b to the 4th. Okay, so I got rid of the coefficients, right? Remember, that was that power to a power rule, just kind of in reverse. Now it's where we can take care of the addition and say, all right, since it's an addition, and again, make sure both sides have the same base. They're both base 3, so we can combine these into becoming log base 3 of a squared times b to the 4th. Okay, because addition, again, relates to multiplication with exponents. Okay, so what I did, I took the original expression here. It was 2 logs being added together. I was able to simplify it and write it as a single logarithm, okay, which will allow us to do some further things down the road. Okay, so just make sure you review those properties. Relate them back again to properties of exponents. These are not completely brand new things, but they can get a little bit, confusing at times, and you just need to practice with them a little bit because we will use them to help simplify and solve some equations coming up shortly. All right.